So on to our next set of notes on the ambiguous case. I did print off a blank set of note sheets, or shouldn't say print off, but I inserted them into Classroom so you'll have these as well, so you can now copy down notes, which probably would have made a lot more sense to kind of been doing this all along. But I did insert a blank piece, so if you wanted to print them off, you can write your own notes down. So what we're moving on to today is all about, again, what we call the ambiguous case. And the ambiguous case concept is all about testing your skills on what you know about the construction of triangles and given certain information. So, in each question that deals with the ambiguous case, you'll be given certain information and then you'll be asked how many different triangles, how many unique triangles can you sketch or make given the information that was provided. So by the time we get to the end of these notes, I want you to be able to think of, regardless of the information that's given, what are the number of possible triangles you can make? Can you make 10 different triangles given certain information? Can you make five? Can you make two? How many is it? Many triangles can you construct given certain information? So that's your question to begin. And again, by the time we get to the end, I hope that you realize how many that is. Um, and by the notes that we go through, that will be discussed anyway. But I'm hoping that along the way, if not already, you know how many different triangles that can be constructed given certain information. So into the ambiguous case. Sam is designing a triangular piece for a metal sculpture. He tells Martha that two of the sides of the piece are 40 and 15 inches. So, as with everything, sketch it just so you know what it's going to look like. You don't know for sure, but just so you have a triangle there. It doesn't have to be the perfect triangle that fits the description, but at least so you can write some numbers down. So, the angle opposite the 40-inch side measures 120 degrees. So that means over here is 120. Martha decides to sketch the piece that Sam described. How many different triangles can she sketch that matches Sam's description? So again, think that you are this architect and you are designing this piece, whether you're actually going to make it or you're actually designing it. How many triangles can you make? Is there just one? Is there five? Is four? How many is there? So we need to figure out, based on information provided, what other information can I find, and then what other triangles can I construct if I know certain information. So to continue on with this, based on our information, I'm going to label some sides. So when we do our calculations, you know which ones that we're talking about. So I'm going to label this one over here is going to be A, this is your B, and this is C. So again, you know which ones we're talking about. So given this information, and as you can see it's sketched, what other information can I figure out? Can I calculate what little c is? Can I calculate angle A? Can I calculate angle C? So what information can I find first given this information? Either using law of sines or law of cosines, whatever it is. And you'll see also by the time we get done which two will or which one of those laws will make the most sense to use given our information. So as we look here, uh, based on our thoughts about law of sines and cosines, I am given a side and an angle opposite that side. So as far as can I use law of sines? Can I use law of cosines? Law of sines is the one that we're going to apply because if you remember, there are two methods when we use law of cosines. Law of cosines uses two sides and the included angle, which we don't have. Or you could use law of cosines when all three sides are known and you need to find an angle measure, which again isn't this case. So we need to use law of sines. So based on law of sines, which one of these three things can I find? Can I find, again, side C? Can I find the measure of angle C? Can I find the measure of angle A? Based on law of sines, we can calculate angle A because, again, we have a side and an angle opposite it. I know the side opposite angle A, so that means I can calculate angle A. And then once I know the measure of angle A, because I know the measure of angle B, I can find the measure of angle C, and if necessary, find side C. So we'll see how we proceed once we start finding information. So to begin with, again, I'm going to excuse me, be able to calculate angle A. So setting up the law of sines. That's the one that we're going to need to begin with. We don't know anything about angle C or side C. So I'm going to put in some values for what we have. So little a is 15. And angle A is what we're trying to calculate. Little b is 40, and angle B is 120 degrees. So we're going to again calculate what the measure of angle A is. So as before, we're going to cross multiply. So we get 40 times the sine of angle A equals 15 times the sine of 120 degrees. I'm going to go up here because I'm running out of room. And then what that means next is that the sine of angle A would be 15 times the sine of 120 degrees divided by 40. Again, we're trying to calculate the measure of angle A, so we would have to do the inverse sine of both sides. So what that would lead us to is to say that the measure of angle A is going to be the inverse sine of 15. Wow, I'm using a pen and the eraser pops up and acts like it actually is doing the erasing here. So let me do that again. So inverse sine of 15. It's like somebody's messing with me on these. I wish I could get that eraser to go away, but it doesn't want to work that way. So 15 times the sine of 120 degrees all over 40. So this is what we're going to calculate. Measure of angle A is the inverse sine of 15 times the sine of 120 divided by 40. So in your calculator, we would do that. And what you're going to end up with is finding that the measure of angle A is approximately 19 degrees. Now, rounding in this case isn't really going to be an issue because we're just trying to see how many different triangles can we construct. It's not exactly what they are, it's just can we make them. So if you remember back to when we calculated exact values of given angle measures, you'll know that this angle is positive. So the sine of some angle is positive. And what that means is, if you again think back to our all students text constantly, the measure of sine is positive in both the first and the second quadrant. So there's two possibilities that I actually have for this right here. So not only is it 19 degrees, but if you think about it, if this is my reference angle, the angle that's in quadrant 2 that this could also be true for is 161 degrees. So those are two possible angle measures that I could come up with for angle A given this information. But now we have an application. Can I actually make a triangle? Remember, this is a piece of metal for a sculpture. Will both of these angle measures work? So if I take just 19 degrees to start with, and then I come back and take a look at my metal sculpture, that means angle A would be 19 degrees. And what you need to make sure you look of, again, is going back to geometry, are two things, is that the smallest angle is opposite the smaller side. And as of right now, we don't know what measure of C is. We could, but we don't know right now. But based on what we do know, 19 degrees is smaller than 120, so it must be opposite the smaller side of what we know, which in this case, again, is true. 15 is smaller than 40, so the smallest angle is opposite the smallest side. So if we went and check the second possibility that you need to make sure of is, can I still get 180 degrees out of all of these? 120 plus 19 is 139. So yeah, that's obvious that we could get a third side that would add up to 180 degrees for all of our triangle. So it is possible that 19 degrees would work for the measure of angle A. What about 161? Would all of that information still work? Which again, the two things are the smaller side must be opposite the smaller angle, and then all three angles must be able to add up to 180 degrees. So if you come back and now look at angle A and think of, can that be 161 degrees? It's possible based on the numbers, but with our excuse me, applications, these two angles themselves are already bigger than 180 degrees. It's 281 degrees. So as far as 161 is concerned, there's no way that I could get another triangle using that angle measure. So how many possible triangles can I sketch using Sam's description? Well, in this case, only one possible. That's it. Because there are only two possible given the numbers, right? This is just some possibility, but when I actually apply these angles to a triangle, one works and one doesn't. So to figure out again how we decide which one works and one doesn't, the two things must be true. Largest side must be opposite the largest angle, and they all must add up to 180 degrees. So that's why that second one didn't work, because they wouldn't add up to 180 degrees. And then 161 is bigger than 120, but 15 is not bigger than 40. So the opposite sides and the angles, as far as being larger and smaller, that wouldn't be correct. So let's see another example. Excuse me for my coughing. We've got some coughing going on. So to continue on, now we have an architect commissions a contractor to produce a triangular window. So again, I know I got a triangular window, just going to make a triangle. Doesn't have to be perfect. The architect describes the window as ABC. So there's ABC. Measure of angle A is 50 degrees. BC is 10 inches, so that's over here. AB is 12 inches. How many distinct triangles can the contractor construct using these dimensions? So again, they're making something, in this case a window. Is there only one possible window that would fit? Because if you're a contractor, you really only want the one that's going to work when you're making something. So you want to make sure that only one's going to work. If there's more or less or whatever, or it's not going to work at all, you need to know that. So let's see what we can calculate given this information. So we have a side and an angle opposite each other. Right off the bat, that tells me I can use law of sines. And from what I have, because I know this side over here, I know 12, then I can figure out the measure of angle C. So what we're going to have to set up is that I know little a over sine A is going to be equal to E over the sine of capital C. And then we're going to plug in and see again how many different triangles can we make. So little a is 10, measure of angle A is 50, little c is 12, measure of angle C is what we're trying to figure out. So as before, we're going to cross multiply, and we get 10 times the sine of C equals 12 times the sine of 50 degrees. The parentheses just help things stay neater. So we're going to try to calculate what the measure of angle C is. So we need to divide both sides by 10. And we get sine of C equals 12 times the sine of 50 divided by 10. And then finally, to get CL by itself, we would need to take the inverse sine of both sides. Plug it into your calculator. Make sure you're in degree mode. And measure of angle C, inverse sine of this in your calculator, you would get a reference angle of 67 degrees. So it's possible we could have that angle be 67 degrees. But again, remember there's two possibilities all the time, because if we're trying to think of positive angle measures for sine, It could be in quadrant 1 or 2, just based on the numbers. Those are always possible, is that we could get 2 of those being possible answers. But we have to make sure that they work in our application. So 67 degrees is the first possibility. What's the angle in the second quadrant that would have a reference to 67 and could also possibly work for this information? Well, that would be 113, just a simple 180 minus 67 to get that other possibility. So in order to see if they work again, we need to come back to our triangle and check to see, can they all add up to 180, and is the opposite side, the largest opposite side opposite the largest angle. So the first one is 67 degrees. So if I think of this being 67 degrees, 67 is bigger than 50 and 12 is bigger than 10. So the larger angle is opposite the larger side, so that holds. And then I can add up 3 angles, whatever this one is. You can definitely go through and do it, but we really aren't concerned. It can be a triangle. So 67 degrees is a thumbs up that I could make a triangle out of. So I'm happy with 67. That would work. Now 113 degrees is the other possibility. So again, 113 is bigger than 50, and 113 is opposite the larger of the two sides. Again, larger angle opposite larger side, that's good. And then can all 3 angles add up to 180? Yep, because 113 and 50 is 163. So this could be 17 degrees over here. And unfortunately now, thankfully, I'm not that construction worker, because there are 2 possibilities that I could be designing for this window. And that may or may not be a good thing, but there's 2 possible triangles that we could make. So they may ask for some more classification or clarification for this if we're actually going to go and construct it. So for this example, there's 2 possible triangles. The first example we had, there was 1. Next example, how many distinct triangles can be constructed if we're given this information? So again, this is just going through and drawing our triangles and labeling information that we're given. So triangle ABC, measure of angle A is 30 degrees. Little a is square root of 34. Side B is 12. So the information that we're given, once again, I have angle A and little a, so I can use law of sines to help me calculate measure of angle B. I can't find C yet because I don't know little c, but because of the information that's given, we can use the law of sines to calculate the measure of angle B. So that's what we're going to do for this one. So again, same idea. Put in your information. So little a is the square root of 34. Capital A is 30 degrees. Little b is 12. And angle B I don't know yet. Cross multiply. 12 times the sine of 30. If you're good, you know the sine of 30 is a half, so you could actually put that in there. But just in case you didn't remember that right now, we could keep going, and then we would divide both sides by the square root of 34. So I'm going to, again, come over here to the side. So we have sine of b equals 12 times the sine of 30 degrees all over the square root of 34. And then we'd have to take the inverse sine of both sides. So we'd have b equals the inverse sine of 12. Now I'm going to put the half in because I was kind of running out of room. Over the square root of 34. Then I'd put this into my calculator. And like before, there's always 2 possibilities because, again, there's that angle in quadrant 1 that we could get. And then there's that angle in quadrant 2 that we can have. They're always possible just based on the numbers. But as far as what actually is going to work, we need to check. So when you type in inverse sine of this into the calculator, hopefully you're doing this as we go along. What do you get? What happens? You get an error, don't you? You get an error for this one. And the reason for that is because, again, excuse me, this value over here is bigger than 1 because 12 times a half, the top is actually 6. This number, square root of 34, is less than 6 because the square root of 36 is 6. So the numerator is bigger than the denominator in this case, so that makes that a bigger than 1. And so I get an error message, which actually means in this case, how many triangles can we make? None. Right? There are no possible triangles for this example. Zippo. None at all. So in the first example, we had one possible triangle. In the second one, we had two. This one, there's actually none that can be made. Again, I'm hoping you're thinking along the way of how many possible triangles you can be made given any information. Finally, working on to this last example. This actually was a Algebra 2 and Trig regions question from years back. So in triangle ABC, so all right, that means I need to construct my triangle, and it's called ABC. If measure of angle A is 40, BC is 10, and AB is 12. Then the measure of angle C. So we are thinking about that one. Can be an acute angle only, a right angle only, an obtuse angle only, either an acute or obtuse angle. So this is, again, multiple choice. This isn't like 4 parts. This is just a multiple choice. Which one of these will work? So jog in your memory back to geometry. What does it mean to be an acute angle? And acute angles are in between 0 and 90 degrees. Again, not equal to them because those are different kinds of angles. So that's why there's no equal sign here. A right angle, right? And that's why there's no equal to here. That would be if your angle was exactly 90 degrees. Obtuse are angles that are measured in between 90 and 180. And then finally, either an acute or obtuse. So it could be either one of those two possibilities. So as far as calculating it, it's still done the same way. 2 possible angle measures that we're going to come up with. But as far as, well, which ones work? So given this information, again, I'm going to take a look and see what I can find. So I have angle A and little a. I have that opposite each other. I have this side, so that means I can find this angle. I only can find angle B after I find angle C. I can't find that first. So we have C over sine C, and then A over sine of capital A. Insert in the information and solve as we've been doing. So we get this equation, 12 over sine C equals sine 40 over 10. And if you're really good now at this point, you can actually kind of figure out and just write down the measure of angle C is going to be the inverse sine, because again, we'd cross multiply, and we'd get 12 times the sine of 40 degrees equals 10 times the sine of C. Then we'd have to divide both sides by that 10. And this is what we'd end up with. Again, if you didn't get that far, you can just do each step but you'll work your way to this. And as far as me telling you to show work and whatever, this is easy algebra. You should be able to go really to that step. But if you don't need it, but if again you can't get it all right straight in your head, that's okay if you don't, and write out all the work. Doesn't matter. But as far as our answers, again, plugging this into your calculator, well, you'll get about 50 degrees for possibility, and that means the other possibility is that the angle C could be 130 degrees. So I'm going to come back and check to see if everything works, to see if it is possible that angle C can be one of those measures. So first check an angle C to be 50 degrees. 50 is bigger than 40, so is 50 degrees opposite the larger side? And yeah, it is, because 12 is bigger than 10. So 50 works. And as far as, do we get 180 degrees in the triangle? 50 plus 40, yep, no problem. We'd have 180 for that. So it is okay if we ended up with 50 degrees as an angle measure. So there's one. And then how about 130 degrees? Again, 130 is bigger than 40, and it is opposite the larger of the two sides, so that holds true. And then 130 plus 40 is 170, so yeah, it is possible B could be 10 degrees. So 130 also is a possibility for that measure of that angle. So as far as answering our question, it could be either 50 degrees or it could be 130 degrees, which means option 4, it could be either acute, because it's in between 0 and 90, or it's obtuse because it's in between 90 and 180. So answer 4 would be your question for that. Right. So for today, make sure you look over those solutions that I posted last night for your assignment that was on Friday about practicing more with the law of sines, law of cosines, and the area formula. Did a little bit with area of parallelograms as well. And again, this Monday is just going through writing these notes down. Hopefully, you printed off the note sheet to begin with and you went through and you copied as you went along. And that question that I was asked first off was, how many triangles are there given any information at all? How many triangles can you possibly make given any information? Well, you can either have none, which is what we did up here. That's possible. Or it's possible that you could end up with a one triangle, as we showed you in the first example. Or it's possible that you could have two triangles like we had here in this example. But there's no way possible that you could have three or more because there's only ever two possible angle measures you could ever end up with based on your calculations. There's never three possible angles that you could end up with. So as far as your answers for these, you could either have zero triangles, you could have one triangle, or you could have two. So this is to hopefully broaden your concepts of law of sines and how triangles are created, or the properties of a triangle. So there isn't the assignment today for this. You'll get that tomorrow because I just again want you to go through this set of notes. If you have questions on these, please reach out. Go back and print it off. If you didn't do it the first time and maybe take your own notes, do it again after you read through it once. Maybe that'll help. And again, if you have questions, email me, send me a message through Remind, and I will talk to you soon.